Welcome GibbsCAM users. Today's video is class number 5, which is also a 2-axis turning part. If you watched the class number 4 where we drew everything from scratch, the geometry and everything else, this is the exact same part. We'll probably add another part, but the exact same part. But this time we're going to be using a solid model and not drawing geometry from scratch. If I bring up the model again, as you can see here, this is the same model. We'll put the print in the description as well as the tool list, but it's the same part we did in class number 4, just using a solid model instead. Now, just like with all Gibbs parts, when you start a new part, especially if you're importing a solid model, you always want to start Gibbs by creating a new part to make sure you have the correct machine and everything before you import a solid model. So make sure you start new, give it a name, go to your document control, make sure you're on the correct machine that you want to program. In this case, the horizontal lathe generic shank here. Don't worry about these dimensions here, anything there. Just make sure you're on the correct machine first and then import the solid model. Now, when you import the solid model, you can just go to File and Import. And you can find the files that you would like to import. This is, in this case, it's a SOLIDWORKS file, but you can see the drop-down menu. You can bring any type of, pretty much any type of file you would like to bring in. Some of these aren't solid models like DXF, but a lot of the rest of these are. So STEP works really well. Parasolid is probably one of the best to bring in. Also, SOLIDWORKS files or assemblies will come in just fine. So in this case, I have the part we're going to do is this one right here, same one we did before. So I'm going to click on Open. And Gibbs is always going to bring in the part in the orientation that the engineer, whoever drew this, put it. So not necessarily it'll be in the correct position that you want to start machining it. In this case, you can see it's 90 degrees off. This is my ZX plane. You can see here, so we need to take this file or the solid model and rotate it. So the best way to do that is just to click on the part, your solid model, make sure face selection is off. Even if face selection was on, it would still grab the whole part because it's a solid. So we'll just grab the whole part, go to Modify 2D Rotate, and it wants to know where's the center position that we want to rotate. Most engineers, when they draw turning parts, will have the origin or the center right through the lathe part. So normally you don't have to change these numbers here. So it can be 0, 0. And we just want to go 90 degrees clockwise. So click on Do It. So the next thing you want to do is, once we have that there, is the best thing to do is just go to Modify. And since this is the only part on the screen, you could do Shrink Wrap or Shrink Wrap Visible, either way. So we'll just do Shrink Wrap. And you can see by doing that, it wraps material around the part. Now you can probably see if I go to my top view that the origin is not in the front of the part. So that's easy to change as well. So let's just go back to Document Control. And if you look at this number right here, this is telling me the solid model is 0.4157 from Z0. So all I'm going to do is go to Modify, Move Part Origin. I'm going to just type in that value, 0.4157, into the Z, click on Do It. And you can see now the Z is in the front of the part, and all these numbers have changed here to reflect what the actual dimensions are of this solid model. As you can see, you got 0, -7, all this information here. So now we need to start filling in the blanks here. We want to face off some material on here, so you'll decide what stock you have from the saw cut that you got from your supplier. So I'm just going to give it 1/8 of an inch there, and you can see 1/8 of an inch there above that Z0 there, the line there. You can see that. It's -7. I'd probably put -7 1/8. So some to face off the back side when you flip it around. Since we did a shrink wrap, it already says this is 8 inches diameter there. And we're going to just leave that stock how it is there. Since we're 7 1/8 inch clear to the back there, I'm just going to say that there is we'll say, I think this last time we did the other part number 4, we said there were 6.5 inches of material off facing forward to the main spindle. Actually, I'm going to change that to 5/8 to reflect the 1/8 of an inch that we have there. And so in the back side, we have minus 0.625, not a minus. That just needs to be that. And you can adjust these how you want. On the 2-axis turning part, these numbers don't matter really too much unless you're using machine sim, which we're not on this part. So everything there looks pretty good. The shank we're using is 1-inch shank. You can see the different ones there, just like the last part here. We're programming in diameter and inches. And these clearances, of course, need to be just like class number 4. We're going to make this 8 1/4. And over here, we'll make this 375 on the Z clearance there. So everything's good to go there. So now that you have your stock size in there and everything else ready to go on there, we need to now extract the geometry. So there's a number of ways to do that, but the easiest way nowadays with Solid Modulus is just click this drop down arrow and click the second one down that says slice spun body. If you click that, you can see it slices the body as if it was being turned. Even if you had a hex on the end or keyways, it would still grab the profile of the outer diameter and inner diameter as if that was spinning. So you can program it right from here, pull your markers in and machine it, but I prefer to extract the geometry in case I want to measure something or get dimensions off there. So you can go to anywhere on the green where it sliced it, just right click, click extract profile, extract geometry extraction, click on do it, make sure it's highlighted, do it, and then you can turn that back off. So there's our geometry for our part, the exact same geometry we did before on class 4. And now we're ready to start machining this. So if we turn on our tools and our cam, you can see here's the tools that we used on class number 4. You can download that tool list as well under the description to get the same tools that we used before. Now I saved the processes so we don't have to fill in all the blanks again, because these will be the same parameters and everything that we used on the same class number 4. So I'm just going to bring these in. So all we need to do is right click and go to load the process, click browse, and there's my processes right there. So first thing I'm going to do is rough the face. So click there, click open. Now if you didn't have the tool list, it would automatically bring in the tool for you, but we already have the tool there, so that's fine. If I open it up, you'll see all the different parameters we set on here. You probably need to update a few things on here to match our part. So I think we set our Z clearance was 3/8. Yep, 3/8 on the Z. So I'm going to say 0.375. And again, when we retract to 0.375. And the material we have on the front is 1/8 of an inch. So 50 thou depth of cut, our speeds and feeds are all exactly the same. So we'll just click on the face of that. And again, grab it to the OD, zoom that up a little bit. We want to face from the outside down, put the black round pointer right at Z0. And we'll click on do it. So now we have the first operation, face it off. So I'm going to clear this out now and do our next operation, which will be load process. And we're going to rough the OD. And again, it's going to bring in the process for us. And we're using the same tool, tool number 1. This time we're just doing an OD there. So let's open this up, make sure our parameters are what they need to be set. Everything looks good there, same as before. So let's just start. We'll start here on the chamfer a little bit and we'll drag it off. Again, you can just right click and move it if you want. If I want to move it 0.1, you could do that. That'll move it off there 0.1. And the best way to get your marker to the back there is Control Shift. We'll go right to there. We'll just go right to pretty much right to that end of that chamfer there. And we'll click on do it. Now we have our roughing done. Okay, the next operation we want to do is drilling. So we'll clear this out. Again, I'll say load process. We're going to do drill. And we'll open this up just to make sure and check our dimensions there. So we need to change a couple things here. I want to change this to 0.375, 0.375. And we faced it off almost all the way off, but I'm just going to put 0 in there anyway. We want to make sure it gets clear through our part. I'm going to highlight this, which is to the edge of the drill. Hold the Alt key down, click on here. I can see that's -7, but remember, you have 1/8 of an inch to go here, so I'm just going to say -7 1/4. Feeds and speeds are the same here, so let's click on Do It. Now we have the drilling done. So our next operation, let's clear this out. Right click, load process. This time we're going to rough the ID. And of course it brings in our tool number 4. Check our dimensions here, parameters, 1.187, because that's the size of our drill, so that's just fine. Everything there looks good. So let's just start on the front there. We'll start off the part, just right click. Sorry, we'll just right click and say move the start by 0.1. Okay. And we're going that direction. You need to choose direction before you click the clearance there, what you want to be. So we'll just change that again. Move by 0.1. Now you can see it moves it out 100 thou in front of the part. Control Shift. Want to end there. A little bit past there, and we'll click on Do It. So that roughed out the bore there. So I'm going to clear this out. Again, right click, browse. We're going to now finish the ID. Pretty much the exact same tool. And we'll just stop short of where it left before. Do it. So now that's finished. So let's clear this out. Right click, browse. This time we're going to rough the undercut. And that's with tool number 5, 35-degree tool. Check our dimensions here, parameters. All that looks pretty good there. Okay, all looks good. Zoom that up. Going to start on the chamfer. Off the part a little bit, and on this vertical line there, just close enough. We're just doing material only, so it's only going to cut where material is left. Click on Do It. So now we have that roughed out. So we could look at what we've done so far. I'll slow it down. There's our OD, roughing, drill, roughing, finish, and rough the outside there. Okay. Okay, next we need to finish the OD, so let's clear this out. Load process. We'll do finish OD. Again, tool number 5. Let's start there. We've already drilled the hole and finished the ID, so I can just start right about there. We're going to cut from the bottom up. So we'll do, actually we'll finish on this little chamfer right there. And off the part just a little bit there. And click on Do It. Now we have a finish pass there. And the last thing we need to do is thread. So let's right click, browse. This time we're going to do thread. And let's open this up. Let's make sure we have everything correct. 12 threads per inch. Probably want to fix this a little bit. We need to be out the front a little bit. I'm just going to say 1/2 inch there. And let's zoom this up so we can get the where we want to end. So I'm going to highlight that, hold the Alt key down. I'm going to click on that little chamfer at the end of the chamfer there, 1 5/8. And we're doing 2 1/2, so 2 3/4. Everything there is good. We really don't need to do run in, run out. And everything there is still the same from when we did part number 4. So we'll just click on Do It. Okay, now let's render the whole thing here. We'll rewind. Now I have this color option here set to op number. We probably want to do it by tool number. That way each tool will have its own color. So you can see if you made a mistake or something, but you can see what each tool is doing. Okay, let's play. Rough. Okay, drill. Rough the ID. Finish the ID. Undercut. Rough the undercut. Finish the OD. And then thread is the last thing we're going to do. Speed that up. And we'll turn that off there so we can see the full threads there. Let's unzoom there so we get back here. Okay, so now our part is finished except for the back side there. And of course, all you need to do is flip this around. You can save this, do a save as a backside. Then you can take the solid model, flip it around, and then program the backside for your op number, your second op to finish the part out. Now that's finished this part here, but a couple other items here. As you can see, the threads are helical, which of course they will be. But if you want to, if you have a graphics card that's not as fast when you're threading, because some graphics cards will not show you the threads threading real fast. It might be real slow in rendering. Mine's pretty fast, but if you want to even make it go faster, what you can do is right click in this blue area, go down to the settings. And if you click on custom here, and you can change this whatever you want. 10,000 a little much for me, so I'm going to change that to 1,000 there. But what you want to click on is circular threads there. So we'll just click apply there to make sure everything's good. And let's render this again. You can see how much faster the threads went on here. Pretty fast, and I don't even have it up all the way. But you'll notice here the threads are not helical, but of course your output code will still have your threading code to cut your threads how they should be. But to render, you really don't need it to be helical if you don't want. This will speed up all your threading processes when you do your op sim, and it'll speed it up quite a bit. So just like that, there's your part. And maybe one last item, if you want to save your operations over here, maybe you have a family of parts, or maybe you have another part coming in that's going to be basically using the same tools and everything, you can save those processes just like I did here. And to do that, you just double click an operation. You can close that. And of course, it loads it over here on the process side. You can just right click and you can say save process list. So you can save it, and then you can give it a name, any name you want, and save it in whatever folder you would like. So that way you can always save your processes if you want and come back to those and reuse them on the next part. So that ends this class number 5. So thank you for watching.